Hello everyone, good morning. Our lesson today is the last subtopic of force and motion 2, which is the elasticity. First of all, we shall take a look at the learning outcomes for this subtopic. It is basically of what are expected for us to learn or to know from this subtopic. There are two learning outcomes for this subtopic where the first one, we are expected to know what is the meaning of elasticity. So, for defining the elasticity, there must be some keywords that we have to remember. We shall see it later. Then, for the second learning outcomes, we will focus only on a spring as the elastic object. We will learn the relationship between the force applied to the spring to stretch it with the extension of the spring. Then, we will see that there is one law in physics that relates the two variables. So now let us think what happens when we apply a force to an object. The force can be either pull or push. When we pull an object, that means we stretch it out. So the object can be said as an elastic object. Elastic object is the object which is capable of being stretched, but not necessarily it can return to its original shape, which is the blue object as the example. The second force is pushing an object. When we push the can, it does not return to its original shape, but it is different for the second object, which we can see it returns to its original shape. So we can classify the can as an elastic object, which it does not able to return to its original shape after force being applied. But how about the sponge? The sponge is elastic as it is not damaged after being pushed. The elastic objects have the property of elasticity, which enable them to return to their original shape and dimensions when an applied force is removed. So this means that we have achieved the first learning outcome, which is to describe the elasticity. Let's repeat the definition again, sentence by sentence. Elasticity is defined as the property of an object that enables it to return to its original shape and dimensions when an applied external force is removed. Now, let's move to the second learning outcome, which is to determine the relationship and the law in physics. The object we shall be focused at this time is only the spring. So, we already know the force can be push or pull. When we push a spring, the spring then is compressed. When we pull a spring, it is being stretched. What we shall investigate here is the effect on the spring, which is the length. The length changes depending on the force. When we compress a spring, the length decreases. When we stretch it, the length is increased. So, now we shall narrow down a bit our focus only on a spring being stretched. Here, we want to see the extension of a spring labeled as X being stretched by a force F. In the picture here is a spring without any load, means no force acting on it except the gravitational force. So, the original length of the spring, we take it as A and no extension yet. When we put a load of mg, the spring is stretched. So the extension is x and the length of spring becomes A plus x. Next, when we put a load of 2 mg, the spring is stretched 2 times longer, which is 2x. So the length of the spring becomes A plus 2x. Do you guys understand the concept so far? Let's see a practice to be familiar with this. So, in this practice, we can see there are three springs, which two of them being stretched by a load. The spring without any load shows the original length of the spring. Let's practice a systematic way on solving this question. First of all, we know that there are only two variables for this topic. For the first step, we shall construct a table with these two variables. The important variables are the force or load and the extension of the spring, but we can also include the length of the spring for more systematic. Then, we read all the words written and look for the key points, information, and we can mark what the question asking for. It says here, there are different weights hung on the spring. The original length of the spring is 15 cm and the length changes as we hang the weight. And here it says that the extension of the spring is directly proportional to the weight hung from it, and so determine the value of W. So we now have identified the key points and information given. We insert the information into the table. Firstly, the force or weight, which are 0, 20, and unknown W. Then, we insert the original length, which is the length of the spring without any weight, 15 cm. No extension here. Next, the length of the spring with weight 25 for 20 Newton and 35 for W. Now, we can calculate the extension of spring for the weight 20 Newton. Original length of 15 cm plus x, we get 25 cm. So, the extension should be 10. Next, we determine the extension for spring with load W. Simply, it is 35 minus 15, so we get 20 cm. Remember, we must always subtract the length of the spring after stretched by load with the original length of the spring. So, now we can see the trend of the extension is by 10 for every weight added. This is what the directly proportional means. Now, finally, we can calculate the value for W. It is just a simple calculation. We started by rating the ratio first. Then, we rearrange this to put the W as the subject, and we can get the value of W is 40 Newton. Now, from this simple practice, we can deduce a formula to lead us to a law on spring in physics. Since we have all the values needed here, we can use this to plot a graph. The extension of spring as the x-axis and the force applied on the spring as the y-axis. Since the extension of a spring is directly proportional to the force applied, this should give us a straight line graph. Now, let's determine the gradient of the graph. We use the basic formula for gradient, which is y2 minus y1 divided by x2 minus x1. So, for this case, we let k as the gradient. The formula now becomes like this. This means the gradient k is equal to force divided by extension x. Now we rearrange to put force as the subject. It becomes F is equal to k times x. This is the Hooke's law in physics. Now let's focus on the gradient k. Firstly, we must learn what are the factors that affect elasticity of a spring. The elasticity of a spring is dependent on the types or materials used. A steel wire spring is stiffer than the copper wire spring. Next, the shorter spring is stiffer. Furthermore, spring with smaller diameter should be stiffer than the bigger one. Lastly, a thicker spring of course will be more stiff. So, what exactly is the stiffness of a spring? Stiffness means the rigidity or the hardness of a spring. So, each spring has its own stiffness or rigidity. In physics, we say this as the spring constant, which is the K or the gradient of the graph just now. This K is the measure of the stiffness with unit Newton per meter. Now, back to the Hooke's law. We already know the formula, which is F equals to K times X, where F is the force with unit Newton, K is the spring constant with the unit Newton per meter, and X is the extension of the spring in meter. So, what is the definition of this law? First, we should acknowledge that elastic material has its limit. When a force exceeds the limit, it is deformed. As the first example is the balloon bursts when it blows too much. The balloon cannot stand the pressure and so it bursts. Second example is the rubber band which is broken beyond its limit. So, what happened to a spring beyond its limit? Permanent deformation happened. So, what can we say about elastic limit is the maximum amount of a stretching force can be applied to an object before permanent deformation occurs. Now, we can give a definition to the Hooke's law. This law states that the extension of a spring is directly proportional to the stretching force acting on it, provided that the elastic limit of the spring is not exceeded. Now, we have achieved our second learning outcome. The law that relates the two variables is the Hooke's law, which states that the relationship of force and extension is directly proportional provided that the elastic limit is not exceeded. With this, we have completed our lesson for today. Thank you for your attention.